All right, taking a look at today, our goal is going to be able to simplify expressions using the distributive property. This is something that we looked at last year. So most of what we're doing today should hopefully be a review of what we did last year. Before we get started, some big things with the distributive property. We do want to talk about something called the coefficient, and it is the number in front of the variable. I will sometimes think about this as the first name of the variable. So if I look at x has a first name of 1 because that's its coefficient. Mathematicians are lazy and they got tired of writing 1s all the time, so they quit writing them in some places. And this one here, when we think of x, we think of just having 1x. So when it's not written there, it's implied that that's a 1. So if you see just an x, that has a coefficient of 1. If we look at 3x, this has a coefficient of 3 because that's the number in front of the variable. In this next one, if we take a look at negative x, again, there's not a number written there, but there's a hidden 1 there that, again, mathematicians got tired of writing. So really, the coefficient on just negative x is really negative 1. What we're going to be doing is using the distributive property. We're going to be doing this in the symbolic way, using our algebraic expressions. You can also use it numerically to help make some of your adding and multiplying your order of operations stuff a lot easier. That's not going to be our focus at all. Our focus is going to be on algebraic expressions, so you'll only see this one kind of more in that symbol form. Whenever you hear about doing the distributive property, our goal is always to get rid of the parentheses. So in this one here, to get rid of the parentheses, what's happening is the number that's being multiplied times the parentheses. So think about how you would say the expression. As soon as you say times something and it's connected to the parentheses, that's what's being distributed. So in this first one, I'd read this as a times parentheses. This a is hopping to everything inside the parentheses. So a times b plus, now that a is going to hop to the other part too, and that's where that a times c comes in. Now this one here has a plus sign here, which matches up with this. I'm not going to say it's always going to happen that way. I'm actually going to show a way where you're always going to have a plus sign between these two chunks as we go through some of our examples. Even if there's a minus sign in the parentheses, the process still works, that you can still have that a or whatever is being multiplied to the parentheses can be distributed to both parts. Even if that a or whatever is being multiplied times the parentheses comes at the end of the parentheses, it still works the same way. That a is still going to go to the b, and this a is still going to go to the c. So you still get both of them, but basically what we're doing is we're multiplying in just a different order. Get the same value, but just multiplying in a different order. Same thing again, if there's a minus sign in that parentheses, that number that's being multiplied still jumps into everything inside the parentheses. So this is what we're going to be focusing our time on today. Tomorrow we're going to add a little bit more to it. Before we get started, there's some really important things that we need to talk about the difference of. The first thing is talking about when we're adding variables, you keep the variable the same. So you want to think about when you are adding, how many do you have all together? If you were to look at this first example, there's 1x plus 1x. There's an x plus an x. You would tell me, Mrs. Haugen, we have 2 x's. So when you add, you're adding those coefficients that are in front of the variables. We're going to see that more tomorrow. You won't see any of that today where you're worried about that. You're going to see when we are multiplying variables that you add the exponents. So when we say x times x, again, mathematicians are lazy. They didn't write those little 1s in there. So when we add them, this is really x squared because 1 plus 1 is 2. You'll be seeing ones like this a lot, so you'll get used to seeing anytime it's an x times x, you're going to be thinking x squared. This part here, this is the new part for this year compared to last year. So if this makes sense to you, if you can say, okay, multiplying two variables, I'm going to come and it's going to end up being a squared, and then you're ready to rock and roll. A lot of the math teachers will use this diagram just as a way to kind of visually help students understand some things. If you went to the zoo and you saw a zebra and another zebra, you would come and tell Mrs. Haugen or whoever, hey, I just saw two zebras at the zoo. You wouldn't never say that I had a zebra times another zebra at all. Like, that doesn't make sense. So that's why it doesn't make sense for x times x to mean the same thing as x squared. So again, that's why this one doesn't work either. So try to remember with the zebras that if you were adding, you put them together. If you're multiplying, it becomes a squared. So this would be like zebra squared, because there's two of them and we're multiplying. Just something silly. Now let's start taking a look at some examples. What we're going to look at in each one of these, we're always going to ask ourselves if we need to do keep, change, or add up to begin with, because again, we don't like subtraction. And then we're going to identify the number that needs to be multiplied through the parentheses. So in example A, I don't see any subtraction. We're ready to distribute. I'm going to distribute the number that's being multiplied to the parentheses. I would read this as 4 times parentheses. Okay, that tells me the 4 goes to everything inside. So 4 times 3 plus. Anytime you're moving and hopping to the next one, you're always going to put a plus sign, and then you're going to hop to the next one. 4 times 6x. This step here is showing your work. You don't have to do it. I strongly recommend that you do. Students who do this step here make far fewer mistakes than students who don't. If I start to see that you're not doing this step and you're making a lot of mistakes, I will make you start to do this. Okay? So here, all we're doing is actually physically writing out the distributive property, but now what we're going to do is actually multiply. 4 times 3 is 12 plus 4 times 6x. Multiply the numbers. 24. There's only that x, so it stays as an x at the end. When you're writing these, notice that I put the number in front of the letter. I definitely encourage you guys to do that. It'll help with finding like terms, which we'll worry about tomorrow. Today, you do not need to worry anything about like terms. So after you distribute and multiply, this is going to be your answer because these two are not like. Let's take a look at example B. For this one, I see some subtraction right here in the parentheses. So we're going to do our keep, change, and I'm going to squeeze in a little 1 there. Now I'm even going to see if I can make my negative just stand out a little bit more. It's important to make sure you can see that negative. A lot of students will do the keep, change, but they will miss it because it kind of blends in with the rest of their work. So just make sure it's visible so you can see it. Now we're going to multiply just like we did in example A. That negative 3 times parentheses, so the negative 3 goes through. Negative 3 times a negative 2 plus negative 3 hopping to the next one, negative 3 times a negative 1y. Again, this is showing actually doing the distributive property. Now we're going to multiply. Again, no calculators on this. You're going to do a negative times a negative becomes a positive, and when you multiply, it's a positive 6. Plus negative 3 times a negative 1y. Again, if there's a letter and there's only one of them written there, just multiply the numbers and tack on the letter. Negative 3 times a negative 1 is a positive 3. Tack on the y. There's your answer. Okay, let's look at another one. On example C, again, I see some subtraction, so I'm going to do my keep, change, change. And you can always squeeze in a 1 there in front of that variable, so that way you can definitely see what the coefficient is. You do not have to. It's all on your preference. Now in this one, you'll see that there are 2 parentheses. The first parentheses, all that's in there is -4. So those parentheses are just helping the reader to say, hey, this is the number -4, don't get confused, kind of thing. So all that -4 is going to do is that's what's going to be multiplied into the parentheses. -4 times 6. Moving to the next part of our hopping, so we always put a plus sign and multiply to the next one. -4 times a -1n, and then multiply. -4 times 6, -24, plus -4 times a -1 becomes a +4. There's my only n. And there's our answer. Example D, hopefully this one you're like, that looks really strange, not quite what we've seen before. Ironically, this one is actually still very, very similar to everything we've done so far. First thing you tell me to do, hopefully, is to do our keep, change, change. And then in D, there's a negative in front of the parentheses, but there should be a number. Again, this is mathematicians getting lazy. There's really a 1 outside of that parentheses. And that is what we are going to distribute into the parentheses. So I'm going to think about -1 times 6. Always put a plus sign. Then -1 times a -3x. Multiplying. -1 times 6 is -6. Plus -1 times a -3x, +3x. There's your answer. Again, those two are not like, so that's our answer. What I would like you guys to do now, I would like you guys to go ahead and do E and F. So go ahead and pause the video. When most people are done, go ahead and press play and take a look at your answers and see if you guys agree. See if you can help each other out in case someone has some difficulty with it. All right, taking a look at example E. Distributing that 4, you should have ended up with 4x plus a -12 for this one. On example F, distributing that -2 through the parentheses, you end up with a +2x plus 12. All right, this next set that we're going to take a look at, this is our one new part that we need to take a look at for this year. In example G, there's no subtraction sign. So I'm going to take the whole chunk that's being multiplied times the parentheses. And that chunk is actually 2x. And I'm going to multiply it times x because that's inside. Plus 2x going to the other number times 1. Now go ahead and multiply. There's only a number 2 here, so I'm going to have that 2 there. Then what did we talk about earlier today? X times x is x squared. Plus 2 times 1 is 2. This x also comes along. And believe it or not, these two are not like, and again, we'll talk about why that is tomorrow, but those two are not like, so we do not add them anymore. Example H, I see subtraction, so I'm going to do my keep, change, change, or add the opposite. 3x is multiplied to the parentheses, so we're going to do 3x times 5x plus 3x, times -8. And now we multiply. 3x times 5x. Focus on just the numbers. 3 times 5 is 15. What is x times x? Hopefully you guys are in your head thinking x squared plus 3 times a negative 8 is negative 24. Tack on the x. Again, these are not like terms. You don't need to worry about those today. Tomorrow you will. So there's your final answer on that one. Let's look at these two. In example I don't like subtraction, so I'm going to do my keep, change, or add the opposite. As we're taking a look at this one, I do have some variables, and the variables don't have a first name, so you're more than welcome to add a 1 in front of those if you would like, but you do not have to. I will never mark you wrong if you don't. It just tends to be easier for students. So I'm going to take that 1x that's outside and multiply it by everything that's inside the parentheses. 1x times 1x. Always, always, always put a plus sign as you move to your next hop. And you'll notice as I'm hopping, I'm actually going through and connecting what's on outside, what's to the inside. The reason for that is to help to make sure I don't miss anything as I'm distributing. Sometimes you'll be distributing to 5 terms as you go through your math career. For us, we'll pretty much just focus on 2 and 3 terms inside the parentheses. Now we multiply. 1 times 1 is 1. X times x is x squared, because you wouldn't say you saw 2 zebras if you're multiplying. Plus 1 times negative 3 is a negative 3x. Now let's go ahead and take a look at our next one. This is the first one where we've seen where if I were to read this, I would read this as in parentheses 3x plus 4 end parentheses times 2x. So you're hearing me say that I'm taking something parentheses times something else. So that indicates the 2x is what's going to be distributed. It does not matter which part inside the parentheses you distribute to first. You'll get the same answer, just written in a different order. For me personally, I've always distributed to the very beginning of the parentheses. So we end up with 2x times 3x. Again, we're always putting a plus sign as we move to the next part. And then 2x times 4. Because again, you're going to end up with the same number of parts as there were inside the parentheses on these. Multiplying 2x times 3x. 2 times 3, careful on this one, is 6. X times x is x squared. Plus 2x times 4 is 8. And then tack on the x. There we go. These last 2 examples for today, I would like you guys to go ahead and try these on your own. When most people are done, go ahead and press play again so that way you can see the answers and the work with them and help each other out as you guys have questions. So taking a look at example K, you should end up with negative 1x squared because we took x times x right here, plus a 7 for your answer. So negative 1x squared plus 7 for example K. Example L. Again, when you distribute, you're ending up with an x times x. So you have an x squared, but a 5 is the coefficient because negative 5 times a negative 1 is a positive 5. Plus sign, negative 5x times 6. Signs are different, so our answer is a negative. 5 times 6 is 30. Bring down the y. Help each other out if you guys have questions on those. Otherwise, your homework is the distributive property worksheet due tomorrow. I am well aware that on the homework sheet, on the homework folder, there are 3 homework assignments that have distribute in them. Make sure you are finding the distributive property worksheet and having that one done for tomorrow and submitting it to the correct one. So you're looking for the distributive property worksheet for tomorrow. And just an FYI that we are map testing again on Monday, Tuesday, and then you'll have the distributive property quiz next week, Friday.